Okay. So we are going to cover a few topics. We are going to cover one more time. In fact, we covered the first topic in previous presentation, including forwarding and redirecting to other web resources, and servlet lifecycle events, and the concept of Invoker Servlet. So as I said, this is a bit of repeat of what we talked about in previous sessions. So including forwarding and redirecting to other web resources. By the way, when I'm saying web resources, I'm talking about another servlet or another JSP. Okay, so let's talk about how we can include another web resource, meaning we are going to get the output from another web resource, and then output will be included in the final response by the calling web resource. So when to include another web resource, when it is useful to add a static or dynamic contents already created by another web resource. For example, like a banner content or copyright information. So adding static resource is like a programmatic way of adding the static contents in the response of the including servlet. So this is the one that calls the included web resource, and included web resource basically generate a static resource. More useful thing is a dynamic web component like a servlet or a JSP page. So basically, including servlet will send the request to the included web component, again servlet or JSP page, and output of that included web component will be then included in the response. So basically, it will execute included web component and then include the result of that execution from the included web component in the response of the including servlet. So including servlet is still responsible for generating response. So things that could be things that included web resource can and cannot do. So included web resource has access to request object, but it is limited to what it can do with the response. For example, it cannot write the body of the response or commit a response because it's not its responsibility for writing the response. Responsibility of creating body of response is including web resource, not included web resource. Because it's not actually doing anything with the response, it cannot set headers or call any method that affect the headers of the response. For example, like a set cookie method. Okay, those are the responsibility of including resource. So how do you include another web resource? Basically, you have to create the request dispatcher object from the context, servlet context object. So you're going to get servlet context object by calling get servlet context of your HTTP servlet, and then once you got the servlet context object, you are going to get the request dispatcher object. Now, when you're getting request dispatcher object, you have to specify the URL of included web resource. In this case, /banner. And then once you got the request dispatch object, then you can use include method of it, passing a request object and response object. Okay, so let's say we have a banner servlet. This is a bit crowded code, but don't worry about the code inside. Basically, this banner servlet just generates a banner, right? In either do get or do post. Okay, so don't worry about the code inside. But basically, if we want to get, if you want to include banner servlet, basically what you do is you are going to specify /banner, and then again when you create request dispatcher object, you're going to pass it, and then you're going to call include method. Okay, so now forwarding to another web resource instead of including. So in including the another web resource, it is the responsibility of including web resource for creating a response. In the case of forwarding, it is actually the responsibility of forwarded web resource. So let's see how we can use forwarding. So when do you want to use forwarding instead of including? When you want to have one web component like a servlet JSP to do preliminary processing, meaning initial processing of the request, and then have another component, servlet JSP, to generate the response, meaning the forwarded. So this is the forwarded web resource that is responsible for generating response. Okay. So basically, partially process the request and then transfer to another component, web component, again servlet and JSP, depending on the nature of the request. So, maybe after some partial processing, you can actually decide whether you want to forward or not. So rules of forwarding to another web resource should be used to give another resource, again servlet and JSP, responsibility for replying to the user, meaning generating response. Okay. So if you have already accessed servlet output stream or print writer project within the servlet, then you cannot forward to another web resource, and it will actually throw illegal state exception. Okay, so coding wise it's pretty much the same. So if you want to forward your control to template.jsp page, you are going to specify it when you create request a dispatch object, and then you are going to call forward method with a request and response. Okay, so the only difference between forward and include is that you're using forward method for forwarding and include method for including. Okay, so let's say this is a dispatcher servlet extending HTTP servlet, and here we are basically set an attribute in the request scope object from the servlet path, and then we are passing the control to template.jsp page. So we are forwarding to template.jsp page by calling forward method. Relatively straightforward. Okay, redirecting to another web resource. So there are two different ways that you can redirect a request. So method one is that you can call set status with sc moved permanently, and then set the header with location of this. Okay, this is the destination. The redirected URL. A bit simpler scheme is you can call just send redirect and then specifying the URL. So this method 2, second method, is a bit more simpler than this scheme. Okay, moving forward, servlet filters. So here we are going to talk about what is and why servlet filters, and how our servlet filters are chained. You could in fact have a multiple servlet filters, so you could chain them, and then we are going to see how we can create a filter, and then we are going to see how you are going to configure filters in web.xml file, and then we are going to actually build and deploy servlet filters and see the code. So what is and why servlet filter? So servlet filter is basically the interceptor. It intercepts incoming HTTP request, and it intercepts outgoing HTTP response, and then you can do anything you want. Okay, so the things you can do in the form of filters include marking access, blocking access, meaning you can actually stop processing of that request. You can just return the response. Caching, compression, logging, authentication, access control, encryption, content transformation, anything that you want to do before the request is being handled by the servlet, final destination servlet or JSP page, you can do with a filter. So filters can be chained and plugged into the system during deployment time. So you can specify set of filters in the web.xml file, and they will be chained in the order they are specified in the web.xml file. Okay, so it is available from Servlet 2.3. So again, the things you can do inside a filter is you can take a look at the request headers. You can customize a request object, meaning you can change the headers, you can change the bodies and things like that. And so that is what you can do for incoming request. You can also customize response object. So you can change the response headers and things like that. So this is actually happening when response is captured, intercepted on way out. And then you can invoke next entity in the filter chain, meaning again the filters could be chained, right? So once you're done, you can actually call the next filter in the chain. And you can examine response headers after it has invoked the next filter in the chain. And or you can even throw an exception to indicate an error in processing. In that case, you are basically stopping the handling of the request. Okay, so a few use cases. So you have many servlets and JSP pages that need to perform common functions such as logging or XSLT transformation. So instead of actually changing all those servlets for, let's say, logging or XSLT transformation, you can create a filter and then you can configure that filter for all servlets. Okay, so in that case, it's actually more modular, and you have a reusable functionality. In this case, logging that can be chained to all servlets. So in this case, build a single logging filter and then or compression filter if you want to perform compression or XSLT transformation, and then you plug them at the time of deployment, actually changing web.xml file. Well, it's not complete true, meaning at the time of deployment, you still have to create a WAR file that contains web.xml file. So you still have to actually rebuild the WAR file in order to change a filter or configure a new filter. Okay, how do you separate access control decisions from presentation code? Suppose you have again set up JSP pages and servlets, right? Those are web resources. And if you want to impose some kind of access control, again, instead of changing each servlet or JSP page, you can actually have a filter that performs the access control. Okay, so build and deploy access control servlet filter. I should say filter. Use case number 3. So you may have many existing web resources, servlet JSP pages that need to remain unchanged except a few values such as banners and company name. And in that case, you do not want to make changes to those existing resources every time company name changes, right? So in that case, you can actually create banner replacement filter or company name replacement filter, and then that filter will actually change the banner or company name for each request and each response. Okay, so how can you chain filters, servlet filters? So this picture shows how filters are chained. So the request comes in, and the first filter will handle the request, meaning it will intercept it and do something about it, and then it will pass the request to the next in the chain, and the next in the chain. Eventually, it will be handled by final destination servlet or JSP page, and then it will be going through the other direction. Okay, so now filter N will handle the outgoing response message first, and then it will pass it to the next one in the chain. Okay, eventually filter 1 is going to handle outgoing response message, and then it will send to the client. Okay, so the way that a filter is going to pass the next in the chain is basically calling doFilter method, passing request object and response object, and also passing filter chain. So as we talked about, multiple servlet filters can be changed. The order is dictated by the order of filter element in web.xml file. So the first filter of the filter chain is invoked by the container. Okay. And so the doFilter method of it will be invoked, and the container will pass servlet request object and servlet response object as well as filter chain object. Okay, and then filter will perform whatever logic it wants to perform, for example, access control or authentication, XSLT transformation, logging, or whatever that the filter is designed for, and then call the next filter in the chain by calling chain. So doFilter method of this filter chain object. Okay. So last filter in the chain, when it calls chain doFilter method, it will call the service method of the final web resource, in this case servlet or JSP page. Okay, so let's see how we can create a filter. So the filter interface, so javafx.servlet.filter interface has two methods, init and destroy, for initialization and for cleanup. The important method that you want to override is doFilter method. So doFilter method will receive servlet request object and servlet response object as well as filter chain object from the container. So doFilter method gets called each time a filter is invoked, and it handles, it contains most of the filtering logic, again, in XSLT transformation, access control, or whatever you want to perform. And servlet request object is casted to HTTP servlet request if the request is HTTP request type. So here we are basically dealing with mostly HTTP servlet request, but filter is designed to handle different request type, but 99% of the time, actually 100% of the time, we are talking about HTTP request type. You can wrap the request and response object, and then you can call the next filter in the chain by again calling doFilter method of this filter chain object. Or you can block request processing by omitting chain doFilter. So if your filter do not call this, then the processing stops right there. So in that case, the filter is responsible for generating response message to the client. And filter can also set the headers of the response for the next entity. Okay, so these are the classes. Filter chain class. So this is passed as a parameter in doFilter method. So this is created. The object of filter chain is created by the servlet container and will pass as an argument on doFilter method of your filter class. And the filter config is passed as a parameter in init method so that you can perform some initialization. Servlet, HTTP servlet response wrapper is a convenient implementation of HTTP servlet response interface. So if you want to create a response message directly, this is the class you could use. Okay. So that is the coding. Now let's see how we can configure filter in web.xml file. So you have to write a filter class and then you have to configure it in web.xml file. So the way that you are going to configure filters in web.xml file is using filter element, and you specify filter name and filter class. And then in the mapping, you are going to use the same filter name, and then you specify URL pattern. So what it means is that whenever this URL pattern is being passed, is actually coming from the client, this filter will be used. Okay, so that's basically what this is all about. So this is an example. So we have two filters. One is order filter. The other one is a hit counter filter. So this filter is defining the name and class of order filter, and for that filter we are specifying URL pattern. So whenever there's a URL pattern of /receipt, this filter will be invoked. Okay. Same thing for this. Whenever there is a URL that ends with the enter, this hit counter filter will be invoked. So question, how does this URL pattern of filter is different from the servlet URL pattern? The functionality is, I mean, the way it is being used is exactly the same. Okay. So if you're using, let's say, this filter, I mean, this URL pattern for servlet, then this filter will be used, and then also the servlet, will be the also invoked. Okay. So the way that we are using this URL pattern, works exactly the same in the case of filter and in the case of servlet. Okay. Okay, so steps for building and deploying servlet filters. So typically, going back here, typically your URL pattern of the filter might actually be the same for URL pattern of your servlet. Okay, but that doesn't have to be the case. In fact, you could use a single filter for many servlets who might have a different, let's say, the URL patterns. Okay. So so let me actually take a look at the questions. Seems like there are questions about this URL pattern. If there is a same URL pattern is applied to a filter and a servlet, which will happen? They will be applied on both. Okay, so suppose you have a filter URL pattern of this, receipt, and if you have a servlet that has the same servlet, then this filter will be applied, and also servlet is in fact the final destination. Okay. If I want to use a filter for one servlet, how do we define? So, you have to actually define this filter separately from your servlet. Okay. So defining servlet does not, indicate that it's actually being applied to a servlet or vice versa. They are orthogonally different. Okay. They are orthogonal, I guess, so basically you have to configure both. Okay. All right. Steps for building and deploying servlet filters. So basically, you decide what custom filter behavior you want to implement for web resource. For, let's say, for particular servlet, you suppose if you want to perform XSLT transformation or logging, then you want to actually create a filter, right? So you have to actually you have to come up with you have to decide what custom behavior you want to have your filter for. And then you are going to create a class that implements filter interface. And of course, the important method that you are going to implement is the toFilter method. Okay. And inside toFilter method, you're going to also pass. If you decide to pass in the next in the chain, then you're going to call the toFilter method of the filter chain object. And then you have to configure that filter with the target servlets and JSP pages, using filter and filter mapping elements, as we have seen in previous slide. Okay, so servlet filter example code. So here we are creating hit counter filter implementing filter interface, and here we are also implementing init method. Okay, so here, we basically receive the filter config object, and then we, in this case, just set these things up. We are not really using in this case. An important method that you have to implement is the doFilter method. So doFilter method will receive servlet request object and servlet response object along with a filter chain object. Okay. So here you are going to, basically check whether filter config is null or not. If it is null, then we return. And then we are going to an attribute hit counter and the counter object. And then we basically write it that the counter value of that counter object. And then we are going to log it. And then finally, we are going to call doFilter method of this filter chain object with a request and in this case wrapper. And so basically we are passing the request to the next one in the chain. Okay, and then we are going to configure this filter in web.xml file. So again, filter name, filter class, and the same filter name has to be the same filter name, and then URL pattern. Okay. All right, so let's try the first demo in the hands-on lab. So if you have a hands-on lab, please, you can download it and try things out with me. This is provided. So if you actually take a look at the hands-on lab documentation, so let's take a look at the hands-on lab documentation. So the exercise one, we just opened the Hello 2 NetBeans project. And this is a way that you can add filter using NetBeans, but you can certainly add things manually. Okay, so you're going to create a filter first. So from new and other and select web and filter, and you're going to name it as my own filter, and you'll provide a package, my package in this case, and then you can configure your filters. So you could have multiple filters. So by using NetBeans, it's basically creating web.xml file. It will add these things in the web.xml file, but you can manually change those things. Okay, and and then we are going to the add code. So this is doFilter method, and in this case, we are going to do some before processing and after processing, and then we are passing the request to the next in the chain. So do do filter. So this one, it will be performed for request, and this is performed after. I mean, this is done. So this is being performed for response message. Okay. So in this case, we are basically getting parameter values of the name, and we are basically just kind of displaying things out. And this is the case. We are going to get request get attribute names, and then we're just kind of displaying things out. And so this is what you're going to actually see. Okay. And when you take a look at web.xml file, basically it contains the filter mappings. Okay. So in this case, if you see the URL pattern, we are capturing every single request. Okay. And that is actually different for servlet patterns. Okay. So they could be different. In fact, they are mostly different, even though it could be the same. Okay. All right. So let's run that application. So here, let's actually take a look at the code one more time. So this is XML file. So here, we are basically capturing every single request coming in. Okay, and this is the my own filter class. Okay, so here we have greeting servlet and response servlet. Okay, and as far as the filter class is concerned, again, this is something that we have seen. So we are basically, the code is, so do filter method, and here we call do before processing, and then we call it, okay, and then do after processing. Okay, so if you take a look at this code, this is before processing. We are just getting the parameter value, parameter names, okay, and in the form of enumeration, then we're just displaying it. Okay, and in the case of do after processing, we are basically getting whatever attributes that are added by the servlet, and we display it. Okay, so if you take a look at the servlet code, greeting servlet is actually including it. So here we are, let's see what we are adding it. Okay, response servlet is probably, yeah, here you go. So we are do get username and displayed. Okay, so let me see. I'm trying to see where it is actually kind of saving any attribute. Yeah, it looks like it doesn't save any attribute. Okay, so it doesn't save any attributes. So after processing is request get attribute names, and here attribute. Yeah, looks like there is some attribute. Let's run this application, and at least looks like there is some attribute that is being added. Okay, so let's say I say Sang Shin and submit, and then we are going to see the logging message. So here, serve the log username Sang Shin. Yes, okay, so this is the after. So basically, do filter, and then this is before processing, after processing, do filter, and do before processing, and the username is Sang Shin. So it looks like a Sang Shin is actually, oh, yeah, it is actually saved as a request parameter. The attribute in the request scope object. Okay, so yeah, that should be the case. Yes. All right. Okay, so that shows how to use the filters. Let's move on to lifecycle events. So the lifecycle events are whenever, so there are three different types of lifecycle events. Lifecycle events could happen when the servlet context object is created and removed, and when attributes are added to servlet context scope object. Same thing for HTTP session. So whenever HTTP session object is created or invalidated, you could get the event notification, meaning callback. Okay, and also changing an attribute. Same thing with the request object. When request object gets created, you can get the callback, and when you add any attribute to request object, request scope object, you could also get the callback. So steps for implementing this lifecycle event. So decide which scope object you want to receive an event notification, whether you want to have an event notification for servlet context object or session object or request object. And then you are going to implement the appropriate interface, depending on what scope object that you want to receive event notification. And then you are going to override methods that need to be responding to the events of interest. And then you can actually access some important web application object, for example, whatever implicit object that are created by the servlet container. And then you are going to configure a web.xml file, and then you can also provide any initialization parameters. So let's see the code. So this is a listener registration. So how you're going to actually register your callback method. Okay, callback listener class object. So web container creates an instance of each listener class, and then it registers it for event notification before processing first request by the application. And it registers listener instances according to interfaces that implement and the order they are specified in web.xml file. And then when a particular scope object gets created or attributes are added to the scope object, these listeners are invoked in the order of their registration during execution. So these are listener interfaces. So servlet context listener interface has context initialize method or destroy method. Okay, and so you can actually override these two methods to whatever you want to do when it is initialized or destroyed. When attributes are in fact added or removed or replaced to the servlet context scope object, you can also get the callback in the format of this, like attribute added, and then the context attribute event. Same thing for the session. So you get the session created or destroyed, attribute added or removed or replaced. And this one is also activation listener. So if the sessions are migrating from one server to another, you might in fact actually the servlet container might have to passivate it or activate it. In that case, you can actually getting a callback of this. Okay. Okay, so this is an example of servlet context. I'm sorry, the context listener class that you are creating. So context listener, and it's implementing servlet context listener interface. So you are overriding context initialized method. So here, you might in fact perform application-wide initialization. Okay, so for example, you can, if you want to have application-wide counter for each request comes in, then you might want to have that counter specified, counter created in this context initialization method of servlet context listener interface, servlet context, the object, because this is application-wide. Okay. And this is context destroyed method. So here you are going to perform application-wide cleanup. Okay. So in this case, we are basically, so in this example, we are basically creating an attribute called the bookDB database that could be used by all servlets and JSP pages in this application. And here, context destroy method, we are just cleaning them up once. So this is per application. Okay, so this is how you are going to configure the listener. So you're going to say listener and the listener, and then you provide listeners and the class path of the listener, the one that we just have seen. Okay, so let's see. Actually, I don't have the code, so let's take a look at the actual step-by-step process of how to, in this case, create servlet context. Well, actually, in this case, we are doing bunch of the callbacks. So we are going to call the application my only event listener. Oh, so here we are going to add the listener to hello2 application that we have just created in exercise 1. So here web application listener, and this is my listener class, and it's in my package. And here I'm actually adding context listener and session listener and request listener. Okay, all three of them. So my listener, called my own event listener, implements servlet context listener and HTTP session listener and servlet request listener. So here is the method. We are not doing anything significant here. We are so this is the code that gets created. Okay, and then we are going to add the business logic for each of these listeners. So here we are basically displaying a logging message. Okay, so you're using servlet context.log method. So whenever servlet context gets initialized, we are just logging it. So you should actually see this message just once, right? Because this is application-wide. And then we have implemented another logging message whenever context is destroyed. So again, you should see this message just once when application is unloaded. And then we have a session created. So we have, the session created callback method and session destroy callback method. So you are going to see this message for every new client, because each new client will have a different session, right? So if you have 5 clients talking to this application, then you are going to see 5 times of this message. Same thing for this. Those sessions, 5 sessions for 5 users will be eventually invalidated. In that case, you are going to see this message 5 times. And this one is for request. So this one is actually being called for every single request coming in. Okay, and this is request destroyed. So every request is done, request processing is done, you're going to see this. So if 5 users are calling, let's say 30 requests, right, altogether, then you're going to see 30 times of this message and 30 times of this message. Okay. All right, so that is basically it. So in this case, you're actually testing it. You can call invalidate method of the session object. That means, you are closing a session for that particular user. Okay. So when you run the application, you're going to see all these logging messages. Okay, so hopefully you can actually try those things out yourself. Let me actually finish up the presentation. Internationalization. So from Servlet 2.4, which is Java EE 1.4, you can have a locale encoding mapping list in your web.xml file. And you can also call these two new methods, again introduced in Servlet 2.4. So you can call set character encoding method. So instead of actually calling set content type and with this, okay, this is a bit inconvenient, right? Here you can just call set character encoding method. And then you can also get the get content type as well by calling get content type method. Invoker method, Invoker Servlet, is used to execute anonymous servlet classes that have not been defined in web.xml file, and is mostly used for debugging and testing purpose. So rule of thumb is that for every servlet, you have to declare the servlet mapping in your web.xml file, right? But in the debugging or testing purpose, suppose if you got, let's say, many servlets, like 1,000 servlets, instead of specifying all those 1,000 servlets in web.xml file, you can just use Invoker Servlet to invoke the servlet without configuring the web.xml file. So this is mostly for debugging purpose. So for example, first of all, in order to do that, you have to configure in the case of Tomcat, you have to uncomment. Okay, so in order to use the invoker, you have to enable it for that particular servlet container. In the case of Tomcat, you have to the web.xml file of Tomcat, and uncomment it like this. And then you can specify invoker and my servlet. And then what you can do is you can actually use my servlet and then you can use whatever servlet name of your choice. Okay, so you don't have to configure a new servlet 2 in web.xml file. You just configure invoker like this once, and then you can just use the name of the servlet like this. Okay. Again, this is mostly for testing purpose. In real production environment, you will never use Invoker Servlet. Okay, so that's the end of the presentation. So let me just